Hi, welcome to the Calculus 1 lecture series. And this is lecture number 6, part 2. We are in the unit number 1, talk about the limits and the derivatives. And in this lecture, the part 2, we finally be able to formally define what is the derivative of a function here. Okay, so now let's go ahead, go to our lecture notes. Let's continue here. All right. So for the part 1, so we stopped after we finished doing the problem number 5. So we defined what is the slope of the tangent lines and how that related to the average velocity and the instantaneous velocities, right? So now let's take a look. How do we define the function, the f of x at any specific point A here. So this is our definition. So first, the derivatives here. Okay, so the derivative. Okay, so the notations here we use, this is our notation. You can say this is y, you say y prime, or you can say this is f prime. Okay, and okay, so that's what is the, that's what we talk about is we call this the derivative. So when you specifically at the point A here, right? So that's how do we define that this is at the point A. So you say f prime A. All right. So that means the f prime A, this is how do we define it? We said this is the limit. Okay, so this is the limit x approach to A, then the f of x minus f of A, x minus A. Okay, so remember we said that you can do the same way. So for the previous part 1, we say you can do the same definitions here. We have a different way to write it. Instead of using the h's here, you can say when the h getting closer to 0, so this is h, and then this is a plus h minus f of a here. So this is the 2 ways you can do when you try to find the limit find the derivative at the specific point. And now if you want to find the derivative f of x, f prime x in the general form, so you're not at any specific point. So you can say this is the way we say f prime x here, right? Then you can say this is the typical form we use is limit h approach to 0, and this is h, then this is x plus h minus f of x here. Okay, so later, like if the problem asks you to find the derivative at a specific point, this formula, I typically like this formula. I think it's a little easier when they ask you the specific point. If they want to try to find the general forms here, then I typical, so this ones here will be the easier for you to use to find the general form here. Okay, so now let's take a look. So in here, we say f prime A is equal to limit h approach to 0. This is true or false? Of course, this is false. So where is the false? This part is false, right? So this should be the f of A plus h here. Okay, so now the parts, okay, so problem number 7 here, right? So now let's say find the f prime A for the, okay, so find the f prime A for the f of x is equal to the 2x, okay, minus a here. Okay, so we said, okay, so you want to find the f prime A in generals, right? So you can say the f prime A, so you can say the f of, let me use the color here. So this is f of the A, Or you can use the x, x doesn't matter. So this is 2a minus a squares, correct? Okay, then the other ones here, you have a plus h, right? So the a plus h, this will be what? It's 2, the a plus h minus a plus h squared. Okay, so this is really just try to test your algebra skills. So you FOIL it, 2a plus 2h. Then you FOIL this one. So this is a squared plus 2ah plus h squared. Okay, and now this one, see here, this is 2a plus 2h minus a squared minus 2ah minus h squared. Okay, so this is the number one we need to do, right? And the number two, see here, we need to find is f of a plus h minus f of a, and the h is here. Correct? So like we said, as long as you have a good algebra background and be very careful, you will be fine. So a plus h is 2a plus 2h minus a squared minus 2ah minus h squared. And then minus f of a, so it's a minus 2a. Be careful, minus need to apply to the both sides. So it's a squares, right? Okay, now let's see anything we can cancel. A squared, negative a squared, that's good. 2a, oh, that's good. All right, so this is what I have left here, right? So I have, this is h, then this is 2h minus 2ah minus h squared, all right? Did you see something? Oh, yes. In here, you have a h here. So what I can do is here, I can factor that out. So I have a h here. So this is 2 minus 2a minus h, right? Okay, then after I factored out, so h cancel. So what I have here, I have 2 minus 2a minus h. So now the number 3, see here, is a limit h approach to 0, h f of a plus h minus f of a, see here. Okay, so now you have a limit h approach to 0. I already simplified this from the step number 2, right? Minus 2a minus h. 2 and 2a has nothing to do with the h. So here, then these numbers here, this h become to what? Become to zeros, right? So what is my answer? Is 2 minus 2a here, right? So that's what is your general answer. So you can find like a equal to 3, equal to 4, equal to 0.1. So you can find the, the what is the derivative for any value of the a's here. Okay. So now, okay, so the next thing here, we want to find, we know the slope of the tangent lines, right? So the slope of the tangent line at the x equal to a, we did that. So it's the slope of tangent line is really is just equal to the f prime a, right? So this is the slope of the tangent line, because from the previous lecture, the previous part 1, the same lecture number 6, we know this is a slope of the tangent lines here, right? Okay, so so it's a very, very important concept, right? So the slope of the tangent line is just the derivative of that at that point. So I know, from the algebras, right? So from the algebra, okay, so from the algebra, if I give you for a given slope m and the 1 point, let's say x1, y1, what is the linear equations here? We say the linear equation will be y minus y1 equal to the m times x minus x1 here, correct? That's what from the algebra we learn that. So now in here, okay, so in here, I'm going to find the tangent. Oh boy, yeah. Let me erase this one. Okay, so now in here, I'm going to find the tangent lines here, right? So I'm going to find the tangent line. So I know what is the slope. How? We just say the slope of a tangent line is a derivative at that point. So it's f prime a. Good. And what is a given point? Because we say these ones here, they're going to tangent here, right? So this is A, right? So this is a tangent lines here. So this is the f of A here, right? And so this is a terrible drawing. Let's see here. Okay. So that's what we did before. So like in here, right? So if this is A, so we have a given points, right? So the given point is what? Given point is A, and what is this value here? This is f of A, right? This is f of A. So what is my tangent line going to look like? So going to be y minus y1. What is y1 here? Is f of A, correct? All right. Is equal to m. What is the slopes here? Slope is f prime A. So it's f prime A times x minus what? X minus A here, right? So this is a very, very super important formula. That's how do we find the tangent lines here, all right? And just like back to like algebra, you know, you're given a slope and given a point. That's how do we find a line, right? So in here, in order to this tangent line, so this is the key thing. So we know the slope of the tangent line is what? Is the derivative of that functions, right? So you will hear me say again and again, you say, what is the derivative? It's the slope of the tangent lines here. Okay, so now let's take a look. So we said, okay, so what is the answer for this one? I said the slope of the tangent line to the graph at the point is what? Is f what? Is f prime a. That's right. Of course, these ones here, we said we need to provide it what? It exists. Okay, so sometimes the slope will not exist. Okay, and so number 9 here, they say the truth or false. They said f prime x measure the average rate of the change respect to x. So what you think? So this is what? F prime x, right? So we know f prime, the derivative, this is the slope of the tangent lines here. So it's not the averages, right? So we say this is what? This is false. Why is not the average rate of the change? Is what rate is here? We are measuring instantaneous, right? So we are measuring instantaneous rate of the changes here, okay? And now let's take a look at the other problems here. So we said, given that f prime x is equal to 3x plus 2, and f of x equal to x cubed plus 2x plus 1, the slope of the tangent line at the point, okay, x equal to 2, the slope of the tangent line. So like I said, this is such key important things, the slope of the tangent line. What's that means here? One more time. This is the what? It's the derivative, right? So it's f prime x. So they want to find x equal to 2. So what is f prime 2? So they give us, so this is 3 times 2 to the square plus 2. So what is this one here? This will be 14, right? Okay. So now they want to find the equation of the tangent line. So we know the equation of the tangent line, just like we talk about here. We need to have a what? We need to have a slope. The slope we just calculated it, right? So we just calculate that, good. So we just calculate, so we say, okay, I have the slope is 14. Then I also need the point. So let's say at the x equal to 2. So when the x equal to 2, what is my f of 2 here? So f of 2 will be 2 to the 3 power plus 2 times 2 plus 1, right? So what is here is 13. So I do have a point. What is the point? 2 to 13. Okay, now from the algebra, I said, find the line. So it's y minus y1. So it's minus 13 is equal to the n times x minus x1, right? So it's 14 times x minus 2. So if you simplify it a little bit, then this one's here, you can say y is equal to the 14x minus 15, right? So this is our what? Tangent lines here. Okay, now the next thing here, let's say, hey, let's try to find the instantaneous rate of the changes here. Okay, one more time, instantaneous rate of the change. What's that mean? That means f prime x at x equal to what? X equal to 3, so it's f prime 3. So f prime 3, so this will be 3 times 3 to the square plus 2. So what is here? It's 29. So instantaneous rate of the change is 29 here. Okay. Okay, now let's take a look here. The number 11 here. So let's say find the limit. So what is your f functions and what is your a? Okay, so those are really good problems here, right? So this is the limit h approach to 0, 9 plus h minus 3. Okay, so we know if you see the h's here, right? So the definition, so it's a limit h approach to 0. So what is here? This is f of what? A plus h minus f of a. So I know the a here, look here, a from this province here, what is the a? A is a plus h, right? So a is 9. And then here, this is f of a. F of a is become 3. So then you see a square roots here. So you know, so what is f of x here? So the f of x is the square roots of x, right? So now you plug into this formula, you will see, okay, so this is, okay, so it's a plus h. So a is 9, 9 plus h, good. Then minus square roots of 9 is 3. Match, right? So that is what we have from the part A here. Okay, for the part B here, oh, this doesn't have a h. So that means I know I'm using my second definition. So what is x approach to what? Approach to A. So this is x minus a, f of x minus f of a. This one is easy. So in here, immediate x minus a. So what is the a here? This one is a, right? So your a is 2. Okay. Then what is the f of x here? The f of x is here, right? So it's x to the what? F of x is x to the what? 6 power. So now the 64 match, right? So 64 is a what? 64 is 2 to the 6 power, is f of a. So I know this is my a and f of x. Those are very, very good questions because like this type of question really, try to test whether you get a pretty good idea about the definition of the derivatives here. Okay. Then I like the last problems also. The last questions, they said for the function, like in here, right? So they said, which one is the largest one? F prime A, F prime B, F prime C. Okay, so remembers, right? So A, So you have A touch here, B touch here, C touch here, right? So what is this? Right, so how do I know which one? Remember the definition is the slope. All this represent the slope of what? The slope of the tangent line at this specific point. Okay, so let's take a look at A, the slope of the tangent lines, right? So this will be my tangent lines here, the red one, okay? Now B, so this will be my tangent lines here. And the C here, this will be my tangent lines here. Okay, so now, because we know the slope, they all are the slope of the tangent line. So which line have the steepest slope? This one. F plus prime C, this one have the largest what? Largest slope, right? These lines here, because the red lines here, these lines go this way. So this one, F prime, I know these ones here, the red lines here for F prime A, what are these ones here will give me a negative number, right? So because the slope, the lines go downhill, right? So got a negative slope. Then the blue ones here and the green one, they both go uphill. So they both have a positive slope. But the green one, the slope is steeper than the blue one. So that's why we said F prime C has the largest values, right? Because we are looking, remember the derivative is the slope of the tangent lines here, right? At that specific point. So that's why I said the problem number 12 is pretty good problem. Is to try to test your concept. You see, you really understand what that means, right? The derivative definitions. Okay, that's it. And so that's for this videos, and we learned what is the derivative definitions, right? So remember the key things you will hear me say again and again: the slope of the tangent line is the derivative definitions here. Okay, all right, that's it. And so now, looking forward to talk to you in our next lecture about how do we take the derivatives now. Okay, so nice talk to you. Have a good day. All right, bye-bye.